Hello viewers, today we are going to start with the part 2 of chapter nitric acid. In the previous video we have done with the basically manufacturing also we have done, but I have today made a the small flow chart which will help you to understand better, and I'll do all the explanation with the help of this chart only. So let us start. So here in Oswald process we take ammonia and dry air in ratio 1:10. The first, it goes into catalytic chamber. Although the name of the chambers and everything is not there in the syllabus, but still you have to remember only the equations. It's better that you remember the chamber or the place where this reaction is taking place. So first is ammonia reacts with oxygen. See, we are taking air, but in air the main part that is reacting with ammonia is oxygen, right? And in presence of platinum 700 to 800 degrees Celsius you get nitric oxide, water and heat. So the process is exothermic. First thing, right? This process is exothermic. Okay, after that we have the same equation is there if you have done with the chapter of ammonia, when you do with the chemical properties of ammonia, reaction taking place, that is oxidation of ammonia in presence of a catalyst. The same reaction is there. So no, it's not a new basically equation that you are learning here. Next is this NO, because oxygen is already there, it would become NO2 at temperature 50 degree, and this occurs in the oxidation chamber. And after that we have the absorption tower. So in absorption tower what will happen, this NO2 which is formed, water would be sprayed in this particular tower, and oxygen we already have it, so we'll get HNO3. Basically here we get nitric acid, and this is only 50% concentrated, right? One thing that you have to notice here is that we are taking ratio to be 1:10 here, but when you see this reaction, basically the first reaction, here the ratio becomes 4:5. So how that is possible? So here basically the reason is because in here basically the each and every chamber is using oxygen. You can see here also, here as well as here. And also first thing is every chamber is requiring oxygen. That is why the ratio of air is taken as almost 10 times that of ammonia. Second thing is we are taking air only consists of 21% oxygen. So that is why the amount of air taken in each and every chamber should be the amount of air taken here, the volume taken is almost 10 times that of ammonia, because every chamber is requiring oxygen in the air which is only 21%, right? Now let us come to the next part, that here when you get nitric acid, it is only 50% concentrated. Here you will get the fumes, and because water is already there, so it will combine and you'll get nitric acid in liquid form. Now you get this is to be only 50% concentrated, means 50% nitric acid, 50% water. If you want to make it to be more concentrated, you will do distillation. Distillation means you will boil it so that the water in that gets evaporated. So by this process you can only concentrate it to about only 68%, means 32% is still water, right? So if you want it to be more concentrated, we are going to distill it over concentrated sulfuric acid, and you will get your final nitric acid to be 98% concentrated. So 98% concentrated acid is said to be fuming nitric acid. Why the word fuming? Because when you open the container containing this particular nitric acid, you can see the fumes coming out, right? And it is very, very dangerous. And the last part here that we have in the syllabus is only the reactions, that is reaction with copper, carbon and sulfur. So when you take copper with nitric acid, dilute and concentrated, see, only difference is, see, salt would be same, water would be same, only in dilute you get NO, that is nitric oxide, and in second one you get nitrogen dioxide, means you get reddish brown fumes. And you have to write a balanced equation, that is compulsory. With carbon, water and NO2 is same, like see here, compare these equations, water and NO2 is same. Here also this is concentrated, see in all three water, NO2 is same. only this particular thing would be different. Like for copper, it is copper nitrate, salt of metal. Here it will oxidize it, CO2 will be formed. Again, this will convert sulfur into sulfuric acid. So here you can get a question that how with the help of nitric acid you can prepare another strong acid, that is basically sulfuric acid preparation they are asking you. And we have already discussed with few questions that the concentrated nitric acid, after some days it turns yellow in color. What is the reason, right? And how you can remove that yellow color. Along with that, you have done that this particular acid is monobasic. Why? Because HNO3 consists of only one H, and it can give one H positive to a base, so it is a monobasic acid, right? So with this, our chapter is over, nitric acid.